Hi, I'm going to discuss about the two-input NAND gate stick and mask layout diagram. Stick diagrams are the cartoon diagrams for the given electronic chip. So by using this stick diagrams, we can easily identify the chip layout. So to draw the stick and layout diagrams, they are following internationally. Some rules are color coding for stick diagrams. For example, green color is used for N diffusion, yellow color is for P diffusion, red for polysilicon, blue for metal, and black color is used for contact cut. And coming to the symbols, and this is an mask layout symbol. Box contain N diffusion means green color, and P diffusion means yellow color. And this is an polysilicon material. Polysilicon is used to design gate materials. So red color is used for poly and metal is for blue color. And we can see this transistor symbol. These are the stick symbols and these are the mask layout transistor symbol. Either way, any way we can use green over poly or poly over green. This is an NMOS transistor. So anyway we can use source gate drain or else source gate drain this side. So both the ways they can use. And for depletion mode, so implant is required. This is an implant, yellow color, and this is an enhancement mode transistor. This is an depletion mode transistor. For similarly mask layout, green color, box contain, that is right side lines is the end diffusions, and over poly is red color. So this is an NMOS enhancement mode transistor, and this is an depletion mode NMOS transistor. For depletion mode, implant is compulsory. So now we can go with the symbols. Here also you can observe this P diffusion yellow and N diffusion green, poly and metal for blue and contact cut, and these are the sticks transistor symbol. Either way you can use any. So this is the symbol for two input NAND gate, and coming to here, and we know that 0 multiplied 0 0 bar means 1, 0 multiplied 1 0 bar means 1. So like that you will get this diagram anyhow. So we know that the designing process already we know that y is equal to a dot b whole bar. So if multiplication is there and pull down network should be series, then only we can get the output. So both are NMOS, and in the top pull-up network should be opposite. PMOS transistors are there. So and the two parallel. So here it is series and here it is parallel. And this is the stick diagram, middle one. And how to draw I will tell you anyhow. And this is an mask layout diagram. How to draw I will tell you. So this is an stick diagram. There are two NMOS and two PMOS transistors are there. And supply is required for that. I will show you here. So anyhow, I will draw it again. So here y is equal to a dot b whole bar is the NAND gate, NAND output. So if it is multiplication, we know that the pull down network should be series. So this is an A and this is an B, and the two NMOS. So this is the ground. This is the ground, and pull up network should be parallel, completely opposite, parallel, and the two it is PMOS. I'm assuming this is P and this is A. A is there, and so supply is required for every circuit VDD, and between pull up and pull down network we should take the output, then only we can get the easily output. So now it is pull down network is pull down network are NMOS transistors. This is source and gate and drain, again source and gate and drain, and this is source and gate and drain, PMOS, source and gate and drain. Now I will go with stick diagram first, then I will go for mask layout diagram. So stick diagram, I will go with stick. So first stick symbol, so we have seen that the transistor symbol is supply symbol and power supply. Metal is used for blue, so I am taking metal. So this is an metal for blue. You know that this is an metal and used for blue color, and VDD. This is an VDD, and ground is also required. So this is an ground. Metal is blue. Now we can go the transistor symbol. We know that the transistor symbols are PMOS transistors are poly or yellow over here, yellow here. This is original symbol, poly over red. So I am taking two transistors at a time because two transistors are there. So two transistors I am drawing. So that is the reason long wire I am taking. So this is the P diffusion over. So this is original symbol, poly, or else red is horizontal and yellow is vertical. Both the ways you can use, so no problem, both are correct only. So here one transistor poly over red, and here one more transistor poly over red. Now completed. Now we can identify the gate, drain and source. Again this side, source, gate, drain, source, gate, drain. Completed. So top side two transistors completed. This is PMOS and PMOS. Now coming to the down, again we required the two transistor NMOS one. Here also either we can go with vertical and we can go with horizontal. So both the ways you can draw. So and I will go with green. NMOS transistor means green over poly. So this is green, one transistor actually. I am extending here. So this is one transistor. So both are they are adding. So no problem. We can connect both the transistors. So this is green over poly, or else poly over green also correct. If red you can use like horizontal, and green you can draw like vertical way. So both are correct only, no problem. Then we can assign source, gate, drain terminal. I am assuming this is source and this is source, gate and drain. And now I am assuming this is source, gate, drain, source and gate and drain. Now completed. So now we can see this drain is drain, and this is drain is connected to supply in the circuit. So now drain is connected to supply. Here there are two options. We can extend with P diffusion. So because it is poly P diffusion, it is a yellow color means P diffusion. We can extend with P diffusion, or else you can go with metal. So always minimum two options are there. So that's why I'm going with yellow color, because I'm extending. This is yellow. Completed. So now we can give the gate across where we are giving input A. So across the gate A and across the gate A we are giving the inputs. So this is gate, PMOS gate, and this is NMOS gate. So now we can go with metal, or else blue color, or else you can extend the same material poly. So anyhow it is a poly, red color. So I am extending with the poly because most of the time they are going with poly. So if it is same material, no need to mention the contact cut. And here also the gate connected for next to transistor. So across this they are giving input A, same input. Across this they are giving input B. So now this is completed. And then go with where we are giving output sources are connected. Across that we are giving output. Of course that is connected to drain. So here you can see this sources are connected. I am going with metal now. Metal, or else you can extend with same. Metal means blue color. So here I am going with metal. So this is an V out, and that is connected to V out from here to here, drain. So drain of this transistor. So drain of this transistor. And this is the way we need to draw. Of course, this source is connected to ground. I'm going with here also two options. We can extend with metal or else you can extend with green color. Green means it is N diffusion. I'm going with green. So this is an green. Now this is the way to draw the stick diagram. So if you know the symbols, transistor symbols, you can easily draw. And coming to the mask layout, I will tell you. And here also we can see this. We know that already circuit, NAND circuit, y is equal to dot b whole bar, and coming to the pull down network should be series, same process, and A and B pull down network should be in series. This is an ground, and pull up network should be in parallel, completely complement. Opposite, this is complement and this is complement A and B. So this is an supply VDD, and in between only pull up and pull down network we need to take the output, then only we can get the output easily. So now I am going with blue because metal is required, metal blue color, blue. So mask symbol for metal we have seen already, we have discussed. The box contains straight lines is the symbol for supply VDD. So this is an VDD and this is an ground. This is an ground. This is an ground. So it is a ground. And coming to the here we need to draw the two transistors are required, PMOS transistor. For that is yellow over poly, yellow or poly. So we can take horizontally or else vertically also, no problem. Both the ways are correct. So mostly they are drawing easily. So this is an yellow P diffusion. So P diffusion. So P diffusion symbol is right side lines. Right side lines having the gap should be high between them. So this is the P diffusion, and P diffusion over, this is the first transistor I am assuming. So this is an poly symbol is red. So now you can assume that source gate drain, and source. Here also one more transistor required. Here again this is the polysilicon material symbol, again source gate drain, and here also two transistors are required, NMOS transistors. So poly over or else N diffusion over poly. So both the ways we can draw, and even horizontally also. So that's why I'm going for green. This is an green. Originally it is one transistor. So but I'm extending. This is an one more transistor. Now green symbol is N diffusion symbol. So right side lines and the gap between lines are very less. So now I am assuming this is source and this is gate and drain, and this is source and gate and drain. Now we need to give the connections to the supply. We can extend with poly. I am extending with P diffusion. So here the same process. There are two options. We can extend with same material or else one more is poly. One more is metal. So and then I need to give the connection from here to here. Green I am giving. So this is source to ground. I am extending, or else you can give by using metal also. So this is one more method. Then gate connected across that we need to give the input. So this is gate using metal also. One more option is there, but I am going with polysilicon. So across that they are giving, of course, A, and this is B. Again gate connected across that we are giving. You can see this gate B and B. So that's why at a time they are giving. So this is B completed. Now in between source gate drain, so this in between source and gate we are taking the output source and source. So using metal or else same material we need to extend. Metal means blue color, So this is an output. In between source and source, using metal symbol is box contains straight lines. So this is an V out. So this is again that is connected to drain of the previous transistor. So this is then drain. You can extend with male or else extend with blue or else green. So this is, if it is metal, it should be having straight line. So this is the way we need to draw the stick and mask layout diagram. If you know the symbols, transistor symbols, you can easily draw. And metal means blue color. So here mask layout diagram is box contains straight lines is the metal symbol. Thank you.